This video is about standard deviation. We know for one variable data analysis, central tendency to analyze the data. Also, we can use a chart and a graphic display such as histogram, pie graph, stem and a leaf plot to analyze the data. There is another property of one variable data, which is called dispersion, such as box plot, variance, standard deviation, skewness, and so on. In this video, we will talk about standard deviation and variance. For the standard deviation, the notation is a sigma. Variance will be sigma squared. In other words, variance equals standard deviation squared. Let's talk about the concept, dispersion. Dispersion, it helps to understand the variation of data and provides a piece of information about the distribution data. The variability of a distribution is the extent to which the data vary around their central tendency, especially the mean. Range, IQR, variance, and standard deviation are methods used to understand the distribution data. Let's look at these three different kinds of distribution of data. This one is very familiar to us. It's a symmetrical distribution, which means the mean, median, mode are equal to each other. This one we call the left skewed distribution or negative skew. Mean, median, mode are not the same. Here we have a right skewed distribution or positive skew. Mean, median, mode are not the same either. Let's go to example. Find a mean, median, and a mode. Draw the histogram. We have two classes, class A and class B. Both classes, 9 students took the test and got the grades. For class A, this is the data. For class B, this is the data. If we put both into graphing calculator, we can figure out for class A, mean is 55, median 55, mode 55. In class B, mean 55, median 55, mode is also 55. So if you only use central tendency to analyze the data, you will see these two sets of data have the same central tendency. So they are the same. But from the perspective of dispersion, these two sets of data are not the same. Let's draw the histogram for class A and class B first. This is the histogram for class A. This is the histogram for class B. You could see the test grades in class A spread differently from those in class B. The data in class B spread wider than the data in class A, since both data are symmetrically distributed. Therefore, their mean, median, mode are the same. Generally speaking, all the data in class A are closer to central tendency than data in class B. We have a term called the standard deviation. It's used to describe how the data spread. In this situation, sigma A will be less than sigma B because the data in class B spread wider than the data in class A. We can also use graphing calculator to figure out the specific standard deviation value. We will put class A and class B data into L1 and L2. I already put the data in L1 and L2. For L1, press stat, calculate, one variable stats, enter. List is L1, no frequency list, so enter. You will get mean is 55. This is a standard deviation, it's 10. Move down. You could see the median is also 55. Let's calculate the standard deviation for class B. Stat, calculate, one variable stats, enter. This time list is L2, so second 2 is L2, then enter. You could see the mean is 55. Standard deviation for class B is 21.8. Check median. Median is still 55. The standard deviation for class A is 10.0. Standard deviation for class B is 21.8. The standard deviation sigma is a statistic that measures the dispersion of a dataset relative to its mean. It measures how far each number in the set is from the mean. This is the formula. X bar means mean. N is the number of values. Xi is each value in the set. Practice 1. Compare the standard deviation of the distribution. Dataset A, B, C. From the graph, we know dataset C spread widest. So sigma C greater than sigma B greater than sigma A. What about their mean median mode? You could see dataset ABC are symmetrically distributed, which means their mean median mode equal to each other, equals 20. There is another term called variance. Notation is a sigma square. In other words, the standard deviation squared is variance.